Hi guys, welcome to Getting Started, setting up your Python environment for machine learning. The essential first step for any ML enthusiast. Installing Python, setting up virtual environments, and installing key libraries for machine learning. A virtual environment to keep your ML projects organized and dependencies separated. Setting up your Python environment for machine learning. It is the essential first step for any ML enthusiast. It's crucial to have your Python environment set up correctly. Setting up your environment is the foundation of any successful ML journey. Ensure you have Python installed on your system. You can verify it by running the following command in your terminal or command prompt. Python version. Open command window and type the command. Press Enter key to run it. It displays version of Python installed on my PC, 3.12.7. Steps to create and use a virtual environment in Python. Step 1. Install Python. Ensure you have Python installed on your system. Note, if Python is not installed, you can download it from the official Python website. First, head to the official Python website, python.org, and download the latest stable version of Python. Make sure to check the box that says Add Python to Path during installation to save you time later. Step 2. Install virtual environment. To create a virtual environment, first one needs to install the virtualenv package. One can do this using pip, Python's package installer. Pip install virtual environment. Note, if you are using Python 3.3 plus or later, you can use the built-in venv module, so no additional package is required. A virtual environment in Flash development and Python development in general is an isolated workspace for your project where dependencies and packages are installed separately from the global Python environment. It ensures that each project has its own set of dependencies, avoiding conflicts between packages used in different projects. Key benefits of using a virtual environment. Dependency management. Virtual environments allow you to install specific versions of libraries required for your Flask project. This way, you can ensure that your project won't break due to updates or changes in package versions. Project isolation. Each project can have its own environment with its unique dependencies, which helps avoid conflicts. For example, one project can use Flask version 1.1.2 while another uses Flask version 2.0.0 without any issues. Simplified deployment. By using a virtual environment, you can easily create a requirements.txt file listing all the dependencies of your project, which can be useful for deployment and collaboration. Ease of testing. You can test different configurations or package versions in a controlled way. Without affecting the global Python setup or other projects. Cleaner global environment. Your system's Python environment remains clean and uncluttered, as all project-specific packages are installed in the virtual environment. Here is overview of the concept of virtual environment in Python project development. Recall all concepts discussed. Let's now implement what we have discussed till now. Here in this demonstration, I'm going to use command prompt to create the virtual environment. Install required libraries. Activate the virtual environment and test the libraries installed to develop the project. First, we launch the command prompt to set up the environment. Select Run as administrator. CLS command to clear the screen. Now let's test whether Python is installed or not. Observe that Python 3.12.7 is installed. If not installed, then install from official site. Here is the official site to download and install Python. Select proper version for your operating system, Windows, Linux, or Mac. This is downloaded file from the official site of Python. Right-click on it and select Run as administrator. Now make sure to select Add to Path. Remember, a path is an environment variable, which is searched by operating system to execute a command in command window. I cancel installation as Python is already installed on my PC. Create a folder on one of the drive to hold your Python projects. My folder on E drive is PY projects folder. Let's change to E drive. Then cd change directory command to move to the projects directory. This folder will hold all my Python projects. Let's use md make directory command to folder named fp to have the first Python project. Then use cd command to move to the fp folder just created for first project. Observe in the command prompt indicates the path of the Python project just created. It's now time to create the virtual environment for the project using the command Python venv. Recall Python 3.3 Plus has installed virtual environment command. Here, venv is the name of your virtual environment folder, which is created when above command is executed. You can name it anything, but venv or env is common. This will create virtual environment for your project. Bravo! The command is successfully executed and creates the venv folder in the project folder fp. Observe carefully the screen. Here are the contents of the folder created when last command is executed. It's time now to activate the virtual environment created. Use command depending on your operating system. My operating system is Windows, so I copy this command to run in command prompt to activate virtual environment. Observe the command window indicating the virtual environment is activated. Now it's time to install required libraries for the project. They are installed with pip the Python package installer. Let's copy this command and execute on the command prompt in the virtual environment activated. In my next video, you will be introduced to each of these libraries in details. Observe the command window. The libraries are getting installed in the activated virtual environment. The prompt shows that the libraries are installed in the virtual environment. These libraries will be your go-to tools for data handling, visualization, and machine learning. Let's test one of the installed library. Finally, launch Jupyter Notebook by typing Jupyter Notebook in the command window. This will open a web interface where you can write and execute your Python code seamlessly. Executing this command will open a web interface where you can write and execute your Python code seamlessly. Jupyter Notebook is an open-source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. It's widely used in data science, machine learning, and scientific computing for its interactive and versatile environment. Let's copy this URL of the web interface and paste it in the address bar of your browser. Here is the web interface to Jupyter Notebook to write Python code in the cell. Select Python 3 from New Menu option to run and test the program. It run code in chunks called cells and see results immediately. To run a cell, press Shift plus Enter or click the Run button, triangle icon, in the toolbar. The output of the cell will appear directly below it. This code prompts user to enter name and display a welcome message. Code below creates an inline plot of a sine wave, with the plot appearing directly in the notebook. It uses the Matplotlib library in Python, a popular and widely used data visualization library. It provides the ability to create static, interactive, and animated plots and graphs. Now paste the copied code in the notebook cell. To run a cell, press Shift+Enter. Here is the sine wave as a graph as output of the pasted code. Observe the title, X label and Y label. Now let's log out from the web interface. Once done, shut down the web interface. Observe the command window indicating that the Jupyter interface is closed. Once you are done working, deactivate the virtual environment to return to your global Python environment. Deactivate. This removes the vin from your terminal prompt, indicating that the virtual environment is no longer active. Freeze your dependencies. To make sure your project can be easily recreated later, you can create a requirements.txt file that lists all the installed packages in your virtual environment. Pip freeze requirements.txt. Now, anyone who clones your project can install the required dependencies by running pip install our requirements.txt. And there you have it. Your Python environment is ready for machine learning projects. Setting up your environment is the foundation of any successful ML journey. If you found this guide helpful, don't forget to like, subscribe, and stay tuned for more machine learning tutorials. Happy coding! Here is a quick recap of what and how the environment is set up for machine learning projects. Steps to create a virtual environment in VS Code. Visual Studio Code (VS Code) is a lightweight yet powerful source code editor developed by Microsoft. It's widely popular among developers for its versatility, extensibility, and robust features. Key features of Visual Studio Code. Cross-platform support. Works seamlessly on Windows, Mac OS, and Linux, making it a versatile choice for developers on any platform. Extensions Marketplace. Thousands of extensions available to add language support, themes, linters, debuggers, and more. IntelliSense provides smart code completion, method suggestions, and parameter hints for supported languages. Henceforth, we will be using Visual Studio Code (VS Code), a lightweight yet powerful source code editor developed by Microsoft. It's widely popular among developers for its versatility, extensibility, and robust features. Now, it's time to learn and develop web application with Python. Flask, web framework for Python. Flask is a lightweight and versatile web framework for Python. It is developed by Armin Ronischer. It is designed to be simple, easy to use. It provides the essentials required for web development. Flask is flexible, and it allows developers to make choices regarding components they want to use and how they want to structure their application. Here is the typical structure of a Flask-based web application. app.py contains Python code and is the start point of the web application. Models.py defines the database models required for web app. Services.py defines the services defined to be used in the application. It defines the business logic of the project. Templates folder in the project folder holds all the HTML-based web pages of the web app. Static folder has the cascading style sheet to decide look and feel of the application and also has JavaScript code used in web app. Requirements.txt file has all the dependencies required to recreate the application. Steps to create a virtual environment in VS Code. 1. Open VS Code and open the folder where your Flask project will be stored. 2. Open the integrated terminal. View Terminal or by pressing Ctrl+ backtick. 3. Create a virtual environment. Python m venv. 4. Activate the virtual environment. On Windows, venv /scripts/activate. On macOS/Linux, source venv/bin/activate. Once activated, the terminal will show the name of the active environment. Example, venv. If any issue in executing these commands, please do the following. Note: set execution policy, remote signed, scope current user. To be executed, open PowerShell as administrator and paste the above command. Five. Configure VS Code to use the virtual environment. When you activate the virtual environment, VS Code should automatically detect it. If not, you can manually set the Python interpreter. Go to View Command Palette or press Ctrl+Shift+P. Search for Python. Select Interpreter and choose the interpreter located in your virtual environment scripts, Windows, or bin, macOS/Linux folder. Let's download and install Visual Studio Code and configure virtual environment for your Flask-based web application. Download and install VS Code. Go to the VS Code website. Download and install VS Code for your operating system. Here is the official site to download Visual Studio Code. Recall my Python project folder where we have created FP named Python project. Now, we will create second Flask-based project named SP. Let's create SP folder for the second project. I've already installed Visual Studio Code. Let's launch it by clicking its desktop icon. This is the visual interface of Visual Studio Code. Open the folder where your Flask project will be stored. In our case, it is the SP folder. Click to check the checkbox to ensure that the open folder is trusted. The next step is open the integrated terminal. You can open the terminal in VS Code by going to View, Terminal, or by pressing Ctrl plus backtick on your keyboard. You can open the terminal in VS Code by going to View Terminal. Select Terminal from the displayed option. Here is the terminal interface indicating the path of the project folder. Create a virtual environment. In the integrated terminal, run the following command: Python mvenv. This command will create a virtual environment named venv in your project folder. The copy command is pasted on the prompt of the terminal. Press Enter key to run it. The prompt indicates that the command is executed successfully. Also, virtual environment folder is created in the project folder. The scripts folder has Python installed in the virtual environment. Now, let's activate the virtual environment. On Windows, vin/scripts/activate. On Mac OS/Linux, source vim/bin/activate. Once activated, the terminal will show the name of the active environment. Example, venv. Executing command to activate the virtual environment. The prompt in terminal indicates that the virtual environment is activated. If any permission issue in executing the command, execute the displayed command as discussed earlier by opening PowerShell as administrator and paste the above command. Now we need to configure virtual environment to use the Python interpreter from the virtual environment. Configure VS Code to use the virtual environment. When you activate the virtual environment, VS Code should automatically detect it. If not, you can manually set the Python interpreter. Go to View Command Palette or press Ctrl plus Shift plus P. Search for Python. Select Interpreter and choose the interpreter located in your virtual environment scripts, Windows, or bin, Mac OS/Linux folder. Go to View Command Palette or press Ctrl plus Shift plus P. Search for Python. Select Interpreter and choose the interpreter located in your Virtual Environment Scripts, Windows, or bin, macOS/Linux folder. Select the recommended option from the displayed list of interpreters. Let's install Flask and other dependencies. With the virtual environment activated, you can install Flask and other packages. Pip install Flask. Paste the copied command. Recall, pip is Python Package Manager. This will install Flask in the virtual environment. Flask is installed successfully. It also indicates version of pip installed and the command to upgrade it. As can be observed, Flask libraries are installed in the virtual environment as a result of successful execution of the last command. It's time to create the Flask-based application. Recall the typical structure of the Flask application. It requires app.py file in the project folder, and it is the starting point of the application. Click to create the file and named it as app.py. The file is created. Let's check the project folder. Here is the Python for app.py file that import Flask library and create the route path for the home page of the application. It is defined as a Python function with the def keyword. For simplicity, it is only returning a string. Let's indent the pasted code to avoid errors. Let's indent the pasted code to avoid errors. Observe the power of Visual Studio Code, showing instant help of the library being used. Select File and Save All to save the newly created and updated file. To run and test the created Flask application, use the following command in the terminal: Python app.py. Recall, a web application is based on client-server model. A web application is hosted on web server and is browsed on client system or mobile using a browser like Google Chrome or Safari or any other browser. This is a development PC. Therefore, a local web server 127.0.0.1 IP address running on port 5000 by default. Copy this URL and paste it in any browser address bar. It's display the content of the home page, which is programmed to simply display as text message. Press Ctrl+C to stop the web server. Since web server was stopped by pressing Ctrl+C. If many applications are to be hosted at the same time, it requires different port numbers. The default port number can, however, be changed with the following code to any available number. Let's change the code to change the port number. I will just paste the copied code. Save all the changes and rerun the application to check and test that it is now running on port number 8095 and not on 5000. Firewall will not allow by default the newly configured port number. Just click Allow button to allow it. Copy URL and paste in browser. Observe the application is now running on 8095 port number. The host equals 0.0.0.0 makes the server accessible externally. Let's deactivate the virtual environment. So guys, you have learned and mastered using Visual Studio Code, configuring it for virtual environment, and developing a simple Flask application. Let's make this developed web app using Flask a more versatile application by actually adding web pages. In fact, a web application is defined as a collection of web pages. For web pages, recall a templates folder needs to be created to hold HTML pages in the project folder that is SP in this demo. The home function defined in app.py file now should render a HTML file instead of the string. Use any HTML page editor to create HTML pages. I am using Dreamweaver. Now, let's add web pages as HTML pages in the template folder. Make sure that project folder is selected in Visual Studio Code, and then select Create New Folder icon to create the templates folder. Observe Templates folder is created in the project folder SP. Now it's time to create the HTML pages in the templates folder. The index.html page is the home page of the created application. Index.html file created in VS Code. Observe the contents of the templates folder. I have created HTML code for the web pages in Dreamweaver. You can also view the output of the HTML page. Let's copy and paste in VS Code. The HTML code is now pasted. The Python code in app.py file needs to be updated to render the HTML page. Here specify the name of the HTML file, that is index.html. Now save all and run and test the application. These are the contents of index.html file. You can add as many web or HTML pages required in your application. For each page, modify the route and define a function with a meaningful name to render the newly added HTML page. For example, adding about.html page. Here is the HTML code for About page. The output can also be checked. Let's copy it and paste in versus code in the about.html page. Now update app.py file to write code for the route of about page and also a function to render the about page. I copy and paste the selected code and modify it. Update route to /about. Change index.html to about.html in the return statement. Save all the changes and run and test it. About.html is not found. Let's debug the code. Oh God! Forgot to rename the function. Let's rename it to about and save changes. Run and test the application. Yes! Done it! Let's add one more HTML page, say test.html. For testing purpose, let's copy the about.html page and modify it for test page. Let's now add the route for test page and also defines a function to render the test.html page. Save all the updated files. Now run and test the web app created using Flask. That's it. It worked. You can try it your side. All the best. And there you have it. Your Python environment is ready for machine learning projects. Thank you for watching the video. Please subscribe to my channel. Please do like and share the video to motivate me to work more for you guys. Also subscribe to my channel. Thank you once again.